Hey, this is Joe at Gray Bench Electronics. Welcome back to the pedal teardown series where I take apart new and interesting pedals and show you what's going on inside. Today on the bench we have the Fairfield Barbershop. All right, so here we go, Fairfield Circuitry Barbershop. So this is one of a few very popular boutique transparent overdrives. Controls are volume, sag, and drive. Previous versions of the Barbershop did not have this tone switch, but it's a 3-position switch. Center switch is the stock standard Barbershop circuit. To the right is a little bit of high-end roll-off, and to the left is more high-end roll-off. We've got standard input and output 1/4-inch jacks, 9-volt DC power jack, non-switching type. It doesn't appear that you can use 9-volt batteries with this pedal, external power supply only. And we got a standard dome-style Fresnel lens bezel right there. Let's crack the pedal open. Fairfield's going with Hammond branded 1590B enclosures, good quality enclosures like that. Also, I just want to say, I really like the aesthetic choices that Fairfield makes. Very simple, muted, straight to the point, utility forward design. I like that a lot. Fairly simple inside, little PCB. Got our foot switch with its own little daughter board PCB, flat ribbon cable connecting the foot switch to the PCB, 1/4-inch jacks, 9-volt adapter. Let's move right along to removing the guts from the enclosure. We'll have a look at that. All right, so here is the Fairfield Barbershop PCB. We have our 3 transistors here. Q1 is a Fairchild J201. Yeah, Fairchild J201. Over here, Q2 is also Fairchild J201. And then the little resistor in the middle there. Can't really see it, but it's a PN2222A, so equivalent to just a 2N2222. This is the tone control up here. Just looking at the traces very quickly, it looks to me like they're coming over to this capacitor right here and this capacitor here. My guess, I'm going to trace it out and be sure, and then I'll post a little update to the schematic that's available around. My guess is they're probably just caps to ground near the output, just to roll off some high end. I am going to pull out the transistors here and get some testing done on those. Previous versions of the Barbershop did use the Millennium Bypass, which is a bypassing system using a diode and a MOSFET. This is just standard 3-pole double throw true bypass. One of the standard blue foot switches, which are fine. They're reliable. They take a little more force than some of the other switches available now. Here are the potentiometers. We have for volume 100K audio, for sag 10K linear, and for drive 100K audio. The LED is a 5mm orange LED, and the bezel is a red LED, so that gives a kind of cool effect when it's lit up. It's sort of a in-between color. 1/4-inch jacks are Switchcraft, good quality jacks. Like we said, we have the main PCB and then a little daughter board for the switch. That's cool. Pots are sort of at an interesting angle. Nothing wrong with that. Works fine. Soldering looks good. No complaints there. You can see there's regular use of 1/8 watt resistors, which is totally fine. 1/4 watt's the most common size we see, but the power dissipation necessary for these resistors isn't even close to 1/8 watts, so there's nothing wrong there. All right, going to move on to the next step. Going to pull out the transistors and test them. Unfortunately, just with the way this PCB is, that does mean I'm going to have to remove at least 2 of the pots, if not all of them. So let's get started on that. All right, got the transistors out of the PCB. Got Q1 in the jaws of the Atlas TCA 75. Let's give it a spin. We're going to record two values for the JFET. That is IDSS and the cutoff voltage, or VP, or VGS off in this case, is negative 0.87 volts. And let's see, we will also want IDSS. Here we go, IDSS is 770 microamps. This is Q1. I'm gonna give that one more spin just to be sure. Yeah, VGS off, or VP, is negative 0.87 volts. IDSS is 780 microamps. So that's Q1, and that's a Fairchild J201. All right, let's check Q2, which is also same thing, Fairchild J201. All right, here we go. This is Q2. VGS off is negative 0.67 volts. IDSS is 510 microamps, negative 0.67 volts. IDSS 510 microamps. Okay. All right, and Q3 is the 2N2222 or PN2222. MPN silicon BJT, of course, 199 HFE. That's at 5 milliamps in the collector. Let's give it one more test. I'm just gonna write down the HFE for this. 198, okay, so we're gonna call that 198 HFE. So next step, I'm just gonna have a look at the circuit, and I'm going to draw up how the tone switch works, and just that'll be able to be tacked on to whatever schematics are out there for the barbershop. So I was looking around the PCB here, and I started tracing stuff out around the tone switch because, like I said, I wanted to see how that's working. And it is working how I said, which is you're selecting between two capacitors here, just going to ground. If you switch to the right side here, it's connecting a 10 nanofarad cap to ground. If you switch to the left side, it's connecting a 47 nanofarad to ground. So that explains the behavior of it when you're playing the pedal. However, as I was tracing it, I started to see more and more stuff that didn't make sense. And I can tell you, I've traced out the whole circuit now, and I'll put the schematic in the FSB thread. But this version of the barbershop is different than the schematics that are available online, the schematic that Pedal PCB is using for their barbershop. That's not to say those schematics are wrong. This is just a new version. And it's significantly different. So, like I said, I'm going to put the schematic for this board on the free Stomp Boxes thread. You can go and check that out. But now that we tested the transistors, I'm going to reassemble the PCB, put it back in the pedal, and we'll wrap up the video. All right, so that's it for this pedal teardown of the Fairfield Circuitry Barbershop. As with all the pedals I do on the teardown series, it is available for sale in my Reverb store if you want to support the channel and you were thinking about picking up this pedal anyway. Check the link in the description. If you enjoyed the video, I'd appreciate hitting the like button and subscribing, and hit the notification bell if you want to know when I make a new video. Also, if you have a recommendation for a pedal you want to see me tear down next, feel free to leave a comment. I'm Joe from Great Bench Electronics. Thank you for watching.